Okay, welcome back. Today I'm going to be working on this old KWIK-WAY valve grinding machine in order to get it cleaned up, get it working well, so that I can reface the valves on the big cat diesel. Here's a shot of the plate. Valve facing machine. Don't know what year this would be from. I imagine it's quite old, probably from the 20s or the 30s. It's very well built. It's nice. The serial number here, 19122, matches the number punched into the bed here. So it's a pretty well built machine. The more I look at it, the more I realize that this must have been very expensive when new, and definitely made for precision and industrial or commercial use. So I have it partially disassembled now. The tool holder, I guess that's what you would call this, the component that holds the chuck, have that removed. And I'm not going to do much to this except clean it up. It really doesn't need a whole lot, which is kind of nice about this whole machine. It didn't need a whole lot of work. It's in pretty nice shape. Motor's off, little 1/4 horsepower General Electric motor. I haven't taken this motor apart. I think it's just a basic squirrel cage like induction motor. There's nothing fancy going on inside there. It does have some air vents underneath. We'll take a look at, see if there's anything in there. You probably can't see. It's probably just a speed switch in there. Yeah. I don't know. I think we might want to take that apart and take a look in there. Two gibs, I guess you could call these, for the tool slide here. I'm going to leave the feed screw in. It's got a pin I'd have to punch out right there. I'm not going to mess with that. Let's see. What else can I tell you about it? This is the wheel dresser. I don't know if that's a carbide tip or if it's actually like a diamond tip. It's hard to say. But it's got like a little storage hole right here, and you just lock it in with this set screw, and when you want to use it, you pull it out, and it's got a bit of a V groove there, and you set it in this hole, and there's a wedge that sits in that V groove there. You tighten with this wheel, and it holds the tools steady. Little spark catching pan sits down here, which you have to take this off in order to use the diamond wheel, the dresser. So that just kind of slides right on this pin right here. Just like that. So it's a really nicely made tool. I keep saying that, and the more I look at it, the more I realize how just well thought out it is. When you start the tool, you're supposed to, or start the motor, you're supposed to have the slide or the carriage here all the way to the back or the right position. And what that does is it actually activates a clutch so that the lower pulley here rides freely on the shaft. So that's free to spin, and then the wheel is not spinning. When you advance the carriage forward, it drops the clutch out and it engages the wheel. It also that also works on the for the belt drive as well, for the tool holder or the spindle. I don't even know what you would call the spindle. Would this be the spindle here? Or does it have two spindles? I don't even know. So I'm going to just clean everything up here. I have I pulled these two bearing caps off. They're not really bearing caps so much as they are oil well caps, which are very clean inside. Had a little cork gasket on them. There's a little piece of felt there and a little felt rope that drips oil down and lubricates the spindle bearings. So let me flip it upside down here and show you the underside. Alright, well here's the underside of the main body casting. You can see the spindle right here with a worm on it, and that worm drives the lower pulley here. Got a tensioning mechanism here for the belt. Two smaller pulleys. So the belt runs around here, runs up, runs around these pulleys, up around the tool spindle. Sorry about that. And then back down. This is the clutch down here, and that is adjusted with this interesting little tapered screw on that acts on the bottom of this plunger here, and that controls the height of this bolt. Let's see, can I move this? Kind of. And then there's a square-headed screw which runs into the head of that bolt, and as it rides up on it, that takes the clutch in and out. So it's quite a well-built and interesting device. And there's a gear rack under there that this handle acts on. So let me get to cleaning this thing up, and I'll keep you updated along the way. One other thing before I go, I mentioned in the Caterpillar video about new belts for this. So here's the original leather round belt for the valve spindle, and the main flat leather belt for the motor drive. So originally I was going to go with two new leather belts, but in looking up belt material, the minimum pulley required for like this equivalent belt to buy new was something like 3 or 3.5 inches. At least that's what McMaster Carr indicated. That's where I buy most of my belts from. So this here is only about 1.25 inches diameter. This driven pulley here. So I ended up taking a chance and buying some of this belt material. This is geez, I forget what the heck it's called. But if I think of it, I'll let you know. It's very flexible, and you join it together by, they call it welding. It's essentially you just melt the two ends, overlap them, and compress them, join it together. So it's very flexible, and it's got a very I don't know what you would call it, I guess a grippy texture to it. I mean, it's smooth, it doesn't have any texture, but the surface finish on it is such that it grabs very well. And then I just have some new 1/4 inch leather round belt material. So let me get to cleaning this thing. Okay, well, we're continuing on here at a pretty good pace. So far I've got the bed here cleaned up pretty well. Luckily there was no real pitting. There was just some surface rust here. So again, like I said, it cleaned up pretty well. The spindle has also been cleaned. The ways cleaned up. The gibs reinstalled and adjusted. Oop. So the belt, you can see the pulley down there. So the pulley here is loose on the shaft, and there is a key of sorts right there. More like a locking pin, I guess. So as the spindle here moves in and out on the feed screw to move the face of the valve either closer or farther from the wheel, the pulley just stays underneath this cast iron belt guard. There are like little protrusions in the cast iron, one on each side here and the other side, just to kind of keep the pulley in the center. It does move around a bit. And it is loose on the shaft, you can see. It's not a very good fit. It's probably pretty well worn. And it's not something that I'm concerned with. Once the belt gets on there and there's tension on the belt, it should stay pretty quiet. when you move the valve in and out on the spindle, you probably hear the pulley dragging a little bit on either the back or the front face of this guard, but once it's actually running and moving, it'll be fine, I think. So one thing on the downside is I'm missing one of the threaded caps for these oil wells here. I did pull the felts out, clean the felts, and re-lubricate everything, so this little cap seems to serve just fine. I don't know if I'm going to make one of these at some point, or I guess I'm going to have to make 2 of them. That fell right down in there. Well, anyway, so make another one at some point to replace this. But for right now, I'm reassembling the belt drive for this for the valve spindle here. This is one of the pulleys cleaned up. It's just a steel pulley, steel machine pulley with a little bronze bushing in it. So the bushing is pressed in the pulley, and then there's a little sleeve here that is slightly wider than the pulley. So when you tighten the belt down, when you tighten the bolt down, the sleeve is pinched between the bolt and the whatever it's threaded into, and the pulley actually rides on that. Just a steel sleeve. So they're going to clean up pretty well. I'm kind of on the fence about what to lubricate these with. I'm just going to use an engine oil for it, probably a 30 weight oil. I think that anything more thin than that would tend to run out. Or I could always just put some grease on it, and that might have a little bit more holding power. I think the key is to just lubricate these, every couple months if it's being used frequently, which it won't be. So probably every time I use it, I'll end up flipping it upside down and just shooting some oil on all of these bearings. So this is what they look like when they come out of the machine, the steel sleeve right there. So alright, let me keep going. Alright, we're back under the machine now. I've put the new belt on. This new leather is definitely more flexible than what I took off. Let me spin it here. I'm just turning the main shaft now, so just watching the belt as it moves. Here's the connector. Here is pretty much just a piece of steel wire. As it goes around these pulleys, the belt, see right there, it kind of spreads a little bit, but I think it'll be just fine. It is the way you're supposed to connect these little belts. So let me grab the original. So the original belt used a similar connector. Sorry about that. Right here. So same situation. I kind of tried to make this as, get the belts as tight together as possible, and wrap the wire so it had a low profile. I think it'll work just fine. So this pretty much wraps up all of the work on the bottom of the machine. Pulleys are lubricated. I'm gonna just shoot some oil on the worm and the drive gears here while I'm under here, and the clutch mechanism. All of that is also lubricated from the top as well. Let me flip it up and I'll show you the oiling points. Alright, so we're back up at the top of the machine. This little oil cup here feeds a little reservoir on top of the clutch, and it also drips to the fork right here. Can you see the clutch fork there? So you might not have seen a good view of this before, but there's that square-headed bolt right there with some dirt and dust on it, and then there's this pin, which is this pin's height is adjusted with this screw, which is tapered, and you can see now the clutch is in gear, so it's engaged. So we're spinning the entire shaft and the valve spindle. When you move the carriage back, that bolt, the head of that screw strikes the pin there raises up and disengages the pulley here, so it just freewheels. So I'm gonna have to take this apart real quick and clean this up. It looks like this entire rear section is brass, probably acts as a sleeve bearing. So I'm gonna clean that up, lubricate that as well, and wipe the whole thing down, clean it all up. I don't think I'm gonna take out the or take the carriage off the base. I think I'll just pull the oil felts out of these points here and just feed some oil down into the ways. This is the gib side. You can't see it. Well, actually you can. There's the gib way down in there. There it is. And the other side, the dovetails appear to be in real nice shape. Not a lot of wear. And that worm drive for the belt is lubricated from this cup right here. So there's no felt in here, but there is a little bit of old oily goo in there. I'll wash that out. So and of course make new gaskets for the spindle bearing oil wells. So making pretty good progress. It'll be going soon. Well, it looks like we've taken a couple steps back here. I decided to take the slide off of the base here, and I'm glad I did in hindsight. You can see that there's these nice little kind of oil grooves cut into the top surface of the dovetail here. Well, the back side is completely filled with grease and grit and dirt, so I'm glad I took it off. Kind of serves me right. I should have just assumed that I was going to have to take this thing all the way apart to clean it. I can't stand having, machine tools with grit and dirt and grease on in the ways like this. But as I was taking it apart, this machine is still impressing me on the way it was built. This must have been a real top quality piece in its day. So here's the gib. It's got 5 nice pockets drilled there, and it's even got these cuts in it. I guess that allows the gib to flex a little bit as it's tightened down, not be so rigid. It's pretty nice. One thing that was kind of a pain to get out, but it's again really well engineered, was this this bearing assembly for the driven worm gear. This gear is driven obviously by the central spindle here. Sits right in that pocket there, kind of in an upright manner, like that, inside that pocket. Now, this is just a big piece of cast iron with the gear's shaft running through it. It's an excellent fit in there. Excellent fit. The gear is locked onto the shaft with a screw. Pretty interesting. You see that hole right there? That feeds oil to the lower shaft right there, and there's a step or a flat cut on that shaft so that it can run down the entire length of that bore. That gear is fed oil with this cup, like I mentioned earlier. There's a hole drilled all the way through this length, and it pops out on an angle right on top of my finger here and drips oil on the top of that gear and lubricates the gear and the shaft. This assembly is held in place in a good fit hole right here with this wedge. This wedges itself against the outer diameter of this component right in this little hole down here. Let me see if I can reinstall it there. Like that. The base is threaded, and then there's an ordinary bolt that passes through the wedge, tightens down, and pulls it in. So it's really well made. I really like this machine the more and more I take it apart. let's go take a look at the slide itself. Pretty impressive component here. A lot of time and effort to make this part. The clutch I mentioned earlier turns out to be a cone clutch. See, there's the clutch spring right there, and the fork rides in this groove. So again, a pretty neat piece. There's the gear rack here for move the slide back and forth, and then the worm. So again, I'm gonna start cleaning everything up here. I don't know if I'm gonna be able to get this thing done today. I thought this was gonna be a one-day cleanup and get it running project, but it might run into next week. So I don't know how long this video is, but I'll check and keep you updated.